So now that you've seen the implementation in the context of the Prime Checker app, which by the way, you can download and play with, it's part of my GitHub account repository. So feel free to play around with it if you feel like it. What we're going to do now is we're going to evaluate the pros and cons of the Executor interface using that Prime Checker app kind of as a touch point to make things more concrete. So what are some things that are worth noting about this? Well, one nice thing, is kind of the pro, is the Executor interface enables transparent tuning and replacement of the number and the type of the threads separately from the Prime Checker app logic itself. So as you can see here, this is just a little snippet of the code from the main activity where we're going to say, hey, Executor, go ahead and execute the computation that is embodied in Prime Runnable. And the cool thing is this piece of code here remains unchanged whether we use a fixed size thread pool, a cached or variable size thread pool, or a work stealing thread pool. So that's kind of cool. We can keep our code the same and then change the implementation. And remember when I first introduced the Executor framework, I said something that was probably somewhat cryptic at the time. I said, the purpose of this framework is to decouple the management and processing of threads and creation of threads from the rest of the application logic. And this is exactly what I meant when I said that. This is the application logic. This application logic does not know, does not really care what implementation is used. That would be done by some factory method that would appear to initialize the Executor field. However, and here's the cons, here come the cons, not everything is rainbows and unicorns. There are some restrictions for the Java Executor interface. One of the complexities, one of the restrictions is that it only supports one-way semantics of runnables, which means that our Prime Runnable class is tightly coupled with this main activity. Why does that matter? That matters because if you rotate your phone, so if I have my Android phone, and let's see if I can actually demo this, probably too hard to see it far away from the rest of the stuff. But if I go and I hold my phone like this, and then I rotate it, it changes the orientation. That's called a configuration change in Android. And when that happens, what occurs under the hood is that the current activity that's running when I'm in portrait mode and I swap to landscape mode, the current activity is destroyed and a new activity is created. And because we've tightly coupled the Prime Runnable to the activity, if I rotate my phone, it'll complicate configuration changes. There's ways around it, but it's complicated. Another issue here is we've got the isPrime method tightly coupled with Prime Runnable. So the isPrime method is part of Prime Runnable, and this particular implementation, as I mentioned before, is intentionally meant to be slow. But obviously, if I was doing this in real life, I wouldn't want it to be intentionally slow. I'd want to change it. And this particular implementation is very tightly coupled. And even more to the point, even if I replace this brute force method with some other computation, like what is it, the sieve of Arachneos, or however you pronounce that, that's a faster way to do a prime number computation. This is still inefficient relative to some approach that applied caching. So if I was going to do a lot of prime number computations, I might want to cache the results so that if I went back and had a duplicate, I could just look it up in a hash table rather than having to go to the trouble of recomputing it. And recomputing is very slow. So this is just way too tightly coupled for its own good. Yet another problem with the Executor framework, the Executor interface, is it doesn't support lifecycle operations. Does anybody know what this diagram is? I believe it's the Hindu concept of samsara, which is the wheel of life and death, right? So it's like reincarnation. So life cycle is not supported by the Java Executor. In particular, you cannot shut down the Executor, nor can you interrupt or cancel running tasks. So you cannot disturb stuff. You cannot do disturbing, right? It's a do not disturb. You cannot allow disturbances to occur. You can't shut anything down. Moreover, you also can't handle runtime changes gracefully. You have to restart the processing from the beginning, which is also very awkward. Therefore, the takeaway from all this is that the Java Executor interface is often too simple for its own good. It works for really, really, really simple stuff where you don't care that you never can shut anything down. You never want to stop the tasks from running. Once they are started, then you just let them run. You don't want to worry about reconfiguration changes, et cetera, et cetera. There are applications like that, but we will see that there's better ways to do this. And this, of course, motivates the next topic, which will be the Java Executor service. So that's the end of the evaluation of the pros and cons of the Executor interface. And like I said, we'll build upon this to show you more useful interfaces that are part of the Executor framework.